Hello viewers, Wagadaruna taking you through the story for A-Level Applied Mathematics. And this video, we're going to go through the marking guide for Senior 5, Math Part 2, End of Term 2 for the year 2024. So this video is suitable for students in both Senior 5 and Senior 6 offering Principal Mathematics as part of their combination. So this is what we hope to upload in the holiday. So what is ticked means already available on the platform, and what is not yet ticked means will be uploaded with time. So this paper contains section A and B and it is entirely mechanics. So paper 2 was divided into two parts. There is Math Part 2A, which is mechanics, and Math Part 2B, which is statistics and numerical methods. So section A, question 1 says, two forces F1 and F2 have magnitude this and this. Magnitude, know that word magnitude. Acting in the directions this and that, respectively. Given that their resultant is this, find alpha and beta. So alpha and beta are magnitudes, they are not vectors. So when you have magnitude and direction, you can get the vector by saying, so the whole of this is called a unit vector. How do they get a unit vector? That very vector divided by its magnitude. You get a unit vector. Now unit vector or unit direction vector multiplied by the magnitude of the force gives you the force in vector form. We are going to do the same for F2. Unit vector is this, vector is that, so unit vector is this one. Multiplied by the magnitude of that force, you will come up with the force in vector form. So now that I have the vector forces, I can now get the resultant. Resultant is good by adding them. Force F1 plus force F2. And I know F is here. So F is here, F1 is here, F2 is here. So let us substitute. So in vectors, I can equate component by component. I can equate the I component and also the J component alone. So I component means this upper one. This upper one will be equal to this times that plus this times this to give us equation 1. Do the same for the J component, this downer part. You come up with that, which is equation 2. Then you realize that this is here. Okay, so that means that I'm going to substitute equation 1 into equation 2. So the whole of this has replaced this here. So now I have only one unknown. I can simplify and make it the subject. So simplify, make beta the subject, and that's what they wanted. They also wanted the value of alpha. So alpha, I can come back here and substitute for beta to make alpha the subject. And that's what they wanted. Then question 2 says, a particle is projected away from the origin O with an initial velocity of 0.25 meters per second. The particle travels in a straight line and accelerates at 1.5 meters per square second. Find the distance traveled by the particle during the 4th second. Note this word, during the 4th second after projection. So during the 4th second means the distance moved from t equal to 3 up to t equal to 4. So first get the distance moved up to t equal to 3, which is that. Then distance moved up to t equal to 4, which is that. When I subtract the 2, I'll come up with the distance moved from t equal to 3 up to t equal to 4. So now this S3 is the distance moved from t equal to 0 up to from 0 to 3. S4 is the distance moved from 0 to 4. So if I want the distance moved from t equal to 3 to t equal to 4, I'll have to subtract. And that is what they wanted. So now I shall go to question 3. Question 3 says, if vector A is this, vector B is this, and vector C is that, find the vector which is parallel to this and has magnitude of this. So we are given magnitude and direction, and we want to get vector. So first let us get the direction. A plus B plus C gives what? A plus B plus C, it gives this. Then what is the magnitude of that direction vector? I'm getting magnitude because at the end I have to get a unit vector. Actually, it's called unit direction vector. So unit direction vector is this here, then multiplied by the force to come up with the vector force, which is that. So you don't leave the answer with this outside, it must go inside. Then 2, they didn't put units here. Do you see this? No units. They said 50 units. So implying that even you don't put units. If you want to just say the word units, if you put there Newton, that is called King. So don't do that. Okay, then question 4, a stone is dropped from the top of a tower. In the last second of its motion, it falls through a distance which is a fifth of the height of the tower. Find the height of the tower. So you'll come and say that let t be the total time taken. That means that distance moved in time t is h, which is the height of the tower. Therefore, when I substitute using the first, second equation of motion, it will be that u is 0 because they said dropped, and g must be substituted. So we'll come up with equation 1. Then also, they said in the last, do you see this? In the last second, meaning that that distance moved in the last second is this one. S equal to t minus s equal to t minus 1. The same as what we used for when they said during the 4th second. It means s t equal to 4 minus s equal to t equal to 3. So yeah, even during the last second means s when time is t minus s at time t minus 1. So that distance moved is a fifth of the total height. So come and substitute. St was h. So I can get st minus 1. That is s when time is t minus 1. So from the second equation, still where there is t, you put t minus 1, t minus 1. Substitute for u because it was dropped, and g. Then simplify to get 2 equations. Now I have 2 equations and 2 unknowns. I can now solve them simultaneously. Let me substitute equation 1 into equation 2. Where there is h, I put there 4.9 t squared. Open brackets. Collect like terms, you'll get a quadratic equation. So we can now solve that quadratic equation to get the value of t and then finally the value of h, which they wanted. So those are the 2 values of t, but one has to be eliminated. Of course, it has to be this. Because why do we eliminate that? It is because during the last second, it means that it must be greater than 1 second. So that this, you see this, we had t and t minus 1. Now, if I take 0.5 here, I'll get a negative. So you remove this and we take this. as a value of t. Therefore, from equation 1, I can substitute for t to get the value of h which they wanted. Okay, so that was question 4. Now we shall go to question 5. Question 5 says, if vector A is this, vector B is this, okay, find the possible values of the constant lambda if the vectors are perpendicular. So there we shall begin by quoting the condition for perpendicular vectors. Then we substitute for A and B. The dot has to be visible. Then dotting now, this times this gives this times this, and this times that. So use brackets very well. Expand, collect like terms to get a quadratic, which can be solved to get the two values of lambda, and that is what they wanted. Now shall go to question 6. Question 6 says, a car of mass 900 kilograms tows a trailer of mass 600 kilograms along a level road by means of a rigid bar. Okay. The car experiences a resistance of 200 newtons, while the trailer experiences a resistance of 300 newtons. Okay. If the engine of the car exerts a forward force of 3 kilonewton, find the acceleration produced and the tension in the tow bar. So we shall need to make a sketch of the first diagram. So put there the car of weight that. Because of this weight, it means that there will be a normal reaction R1. Then also put there the trailer weight that, and normal reaction will now be. Now these reactions are different because the weights are different. If the weights were the same, reactions will also be the same. So this was the rigid bar which is connecting the two. Tension arrows must point towards each other, 2 and 2. Each arrow must have its own letter T. Then this is the forward force. This is what they told us here somewhere. Forward force is that, so you convert it to newtons. Then shall put the resistances. Before you put the resistance, we should know the direction of motion. That's why you put acceleration. So a force diagram is never complete unless there is acceleration, because it is acceleration which shows us the direction of the resistance. Then I'll put the resistance on the car, which was 200 Newton. Then resistance on the trailer, which was 300 Newton. Yeah, I think I'm good to go. Now we can use F equal to MA. For the whole system, when I combine the whole of this, it means that these will cancel out, so it shall not have any T, but we have this forward force, to the right, and we have two forces to the left, and we have two masses. So put there the force to the right minus the two forces to the left equal to the total mass times acceleration. Simplify to get the value of A. So it is advisable to leave the answer in fraction form. Then now I can choose any of the two. I can choose this or I choose this. Whatever I choose will give me the correct answer for T. So let me first begin with the 6 kilogram mass. 6 kilogram mass, T minus 300 is equal to 600A. I think you know where it comes from. Then substitute for A to get the value of T. Alternatively, now for me what I did, I made a shortcut by considering the whole system. Did you see what I did? Let me first show you something. I considered the whole system. But some students may say, why don't I consider body by body? For example, I consider this alone. I also consider this alone. If you do that, you'll still get the same answer. Let us see how. So considering the 6 kilogram mass, I'll come up with this, which is already here, as seen. But now here I don't know the value of A yet, so I can substitute. That's why I call it equation 1. Then go to the 900 kilogram mass. Come up with that. Simplify to get equation 2. Then I can solve the two equations. When I add, I'll be able to eliminate the tension to remain with A, which gives me that. So I've got the same value of A, meaning that I can still put this A here to get the value of T. So those are the two approaches which you could use. So now we shall go to question 7. Question 7 says, the angle between a force P Newton and a force 3 Newton is 120 degrees. Okay. If the resultant of the two forces has a magnitude of 7 Newton, find the value of force P. So here we need to make a sketch. Now, here it is up to you to choose which force to make horizontal. I can make P horizontal or 3 horizontal. Whatever I choose is okay. Then because there are two forces inclined at a certain with an angle between them which is not 90, we need to use parallelogram rule. So put this very force here and this very force here. But these lines should be parallel, and also this should be parallel with this. Then join the result, get the resultant. It is there. The angle is not yet known, the direction. So after drawing the first diagram, next is to use cosine rule. So cosine rule says this squared will be equal to 3 squared plus P squared minus 2 times 3 times P to give you this times cos 60, where cos 60 is this angle enclosing the 2. Simplify to get a quadratic. Then you can solve the quadratic equation to get the two values of P. But P will not be negative, so we shall take P as 8. Now I want to realize something. Do you see this? I'm not putting there a unit. Why? It is because on this P which was given, a unit was already there. So if I put 8 Newton, it means that when I replace it here, it will now become 8 Newton, which is not okay. So don't put a unit. So that was question 7. Question 8 says, a particle of mass m1 on a smooth horizontal table is tied to one end of an inextensible string, which passes over a smooth pulley fixed at the edge and then under a movable pulley of mass m2. Its other end is fixed so that the parts of the string beyond the table are vertical. Show that the mass m2 descends with an acceleration of this. So there we shall need to make a sketch. So sometimes they can draw for you the diagram, but other times they may not. So you need to know how to interpret the statements given into a diagram. So that is a sketch. Now we are going to put the forces. We shall begin with weight, which acts vertically downwards, and because of the weight, there should be a normal reaction. Then here also weight acting vertically downwards. Now here we don't put normal reaction because this mass is just suspended. For this one, it was lying on a horizontal surface. Then you can put attention where arrows point towards each other, and each arrow has its own letter T. Then acceleration, this acceleration should be twice the acceleration which is here. Then I can use F equal to ma. So for mass m1, there is only this force, there is no opposing force. So this is equal to ma, where a is 2a, so m1 times 2a gives you 2m1a. Then for the mass m2, here now, it becomes 2m m2g minus 2t is equal to m2a, which is this. Then I need to solve. Solving means I have to eliminate tension. So multiply equation 1 by 2 and add equation 2 to it. You realize that this cancels, you remain with this, and this plus this gives you that. Then make A the subject, and that is what they wanted. Okay, then question 9. Question 9 part A says, a taxi approaching a stage runs 2 successive half kilometers in 16 seconds and 20 seconds respectively. Assuming the retardation to be uniform, find Roman 1 the initial speed of the taxi, and Roman 2 the further distance that the taxi runs before stopping. I think let's start with that. So here I need to make a sketch. A sketch will not carry a mark, but it helps you to interpret the question. So that's the first half kilometer, time is 16, distance is 500, half of a kilometer. The next half kilometer, time is 20, distance is still 500. And there's a further distance before it stops, so their velocity is 0. Okay, so we are using second equation of motion. We shall consider motion AB, where S is 500, T is 16, to give us equation 1. Then SC, now here that's where problems come from. Most students want to use BC. When I use BC, it means this is the initial velocity, and there I will have added another unknown, which is not okay. So always remember to maintain the initial velocity. So I have to maintain by using motion AC, where total distance will now be 1000 and total time will now be 36. Still use second equation of motion to substitute for S, for T, here and here. Then simplify to get equation 2. So I have 2 equations, 2 unknowns, meaning I can solve simultaneously. Because I made U the subject, I'm going to use substitution method. By substituting where there is U, I put there this. Now I have one unknown, I can open brackets, simplify and make A the subject. And that's what they wanted. So that is acceleration, but they also want initial velocity. They want initial velocity. So now that I have U, I can go back to equation 1 and substitute for A to get the value of U, which is the initial velocity. Roman 2, they asked for Roman 2. They asked for the further distance that the taxi runs before stopping. Here, it means I'm still going to use distance. I'm still going to use motion AD. So using the third equation of motion, substitute V, U, and A to remain with S as the only unknown. So substitute to get S, then the further distance will now be got by subtraction, and that's what they wanted. That was part A. What about part B? Part B says an overloaded taxi traveling at a constant velocity, know that word, constant velocity, of 90 kilometers per hour overtakes a stationary traffic police car. 2 seconds later, the police car sets off in pursuit, accelerating at a uniform rate of 6 meters per square second. Do you see something? This one is meters per second squared. This one is in kilometers per hour. So the units have to be converted so that they rhyme. We shall see that in the solution. How far does the traffic car travel before catching up with the taxi? So convert from kilometers per hour to meters per second, then make a sketch. That is the taxi. Then we also have the police car. So what I want you to realize is that both the police car and the taxi cover the same distance. But the police car takes less time than the taxi. Okay, when that is understood, we can now use the second equation of motion. So for the taxi, we shall have x distance as that, initial velocity as that, acceleration as 0. 0 because they said constant speed. Then for the police car, so we use second equation of motion. S is x, u is 0, time is t minus 2, a is 6, time is t minus 2. So expand to get two equations. Now I have to, you see this x, so I can equate the 2 to get an equation in t alone. So rearrange to get a quadratic equation which can be solved to get the two values of t. But t cannot be this, so you have to use this. Why? Because of this. Do you see this? If you replace this one here, you're going to get a negative time, which you don't want. So from equation 1, I'm going to use this to get the distance required. And that's what they wanted. Then question 10 says, the figure below shows an inextensible string connected to 12 kilogram mass and 20 kilogram mass, which passes under a movable pulley of mass 30 kilograms, as shown below. Okay. Given that the coefficient of friction for surfaces A and B are this and this, respectively, find Roman 1, the acceleration of the movable pulley, Roman 2, the tension in the string, and Roman 3, the reaction at the pulley. So one is to first redraw the given diagram. After that, we shall now start putting there the forces. We, of course, begin with the weight. Everywhere where there is a mass, there should be weight. And because this mass is lying on the surface, there should be a normal reaction. Here there is weight, but here it's just suspended, so there is no normal reaction. Here there is weight, so there should be a normal reaction. Then tension, it is same string throughout, so tension should be the same throughout. So now we shall go to accelerations. This now here in this setting, whether this is small or big, it is the one to go down. Therefore, this will go this side with acceleration A1, this one this side with acceleration A2, and this will be the average of the total acceleration, which is that. So now that you know the acceleration, you can put now the friction, because friction will always oppose motion. So friction for that, friction for this. Okay. Then now we can generate the equations F equal to ma. For the 12 kilogram mass, I'm interested in these forces alone. So it will be T minus 0.5 R equal to 12A. Substitute for R1. R1 is 12G to get equation 1. Then equation 2, shall you get it from the 20 kilogram mass, where we shall say T minus 0.25 R2 is equal to 20A. Substitute for R2, which is 20G, and get equation 2. Then next will now be for the movable pulley, where we need these forces. So it will be 30G minus 2T is equal to 30 times a half in brackets A1 plus A2. So let's come and write it here. So we have that. Simplify to get that equation. Now next is to solve simultaneously. We have 3 equations and 3 unknowns. So equation 1 times 2 plus equation 3 will give us that. And when we add these, t's will cancel and to remain with this, calling it equation 4. The next equation 2 times 2 plus equation 3, you will come up with that. These will cancel to remain with this. Now equation 4 and 5 have 2 unknowns, so I can solve it simultaneously to come up with that. So in this case, this will cancel to remain with only A1. Make A1 the subject, and that is the acceleration for A1. Then from equation 4, I can get substitute for A1 to get the acceleration A2. So I have A1 and A2, meaning I can get the acceleration for the movable pulley. So acceleration for movable pulley is half the sum of the 2 accelerations, which will give us 49 over 16, which becomes 3.0625 meters per second squared. Then for Roman 2, let me see, what did they ask? Roman 2, they wanted tension in the string, and that's lastly reaction at the pulley. So tension in the string. Tension in the string shall come and resolve. So from equation 1, substitute for this A1, you'll come up with this as the tension. Then reaction, I can choose to redraw the force diagram, or I don't. It is still okay. So when I redraw, that's what I come up with. That will be the reaction at the pulley. So here the concept is that this angle here is divided into 2 halves. So it was 90 divided by 2, you get 45. So this will be 45, 45. Then I resolve along this line to come up with RP being equal to 2T cos 45. Substitute for T, you come up with the reaction they wanted.